everybody. My name is Chester Chen. I'm one of the organizers for San Francisco Big Analytics. So we hosting, type of a meetup talks related to the big data infrastructure, analytics, data engineering, platform versus machine learning related topics. So basically end to end, and some of the visualization and topic as well. So today we have a special guest all the way from Paris. Jean-Yves, he's the CEO of this new startup called Data Mechanics, and he has gave us talk before in terms of how to run Spark on Kubernetes and other infrastructures. So today they have a very special talk related to Spark. He was previously working on Databricks infrastructure teams, so he had a lot of experience in this area. So without further ado, Jen, take over.
Yeah, thank you so much, Chester, for having us, and thank you everyone for tuning in. Yeah, as I said, feel free to ask questions on the chat. I will not be checking it because it's kind of hard to do, but Chester, you can read it out or just let me know. And obviously, we can also take questions at the end. So today's session is about Delight, and Delight is a free and cross-platform monitoring dashboard for Apache Spark that we developed. And so, yeah, without further ado, let me dive in. Quick introduction. I mean, you just said it, Chester, but yeah, prior to Data Mechanics, I was a software engineer at Databricks, leading their Spark infrastructure team, now co-founder at Data Mechanics. I'll cover what Data Mechanics does on the next slide. And maybe you know who you are. I need to guess, though I'd love to maybe connect with some of you afterwards. But I presume Apache Spark users. It's really a talk for all level, whether you're beginner, intermediate, really advanced, whether you're a data engineer, data scientist, data analyst, and also it applies to you wherever you're running Spark, because Delight is when I say cross-platform, I mean it does work on top of any Spark platform. So Databricks, EMR, Dataproc, Spark on Kubernetes, open source, or an on-premise setup, or Glue, Azure HD Insights. I think this talk would be beneficial to you if sometimes you have a hard time troubleshooting the root cause of failures in your Spark jobs, or finding the performance bottleneck of your Spark applications, or yet again, keeping track of your Spark costs. So these are some of the things that Delight was built for. A quick word, about our company, Data Mechanics. At a high level, our mission is to make Spark a lot more developer-friendly and cost-effective. So when we work with customers, we deploy Spark on top of a managed Kubernetes cluster in their cloud account. So we're available on Amazon, GCP, and Azure. So pretty much, an alternative to EMR, Dataproc, Databricks, and maybe to even though the rest of the talk will not be talking too much about it, just if you wonder, this is what it looks like at a high level. It's really a bit of a serverless Spark platform in your cloud account. By serverless, I mean that Data Mechanics will take care of automatically scaling the clusters up and down, provisioning the right type of instance using Spot or on-demand ones. And you just focus on building your applications, whether it's from a notebook, and we support Jupyter Hub, Jupyter Lab, Jupyter Regular, whether it's from your IDE, whether you're submitting it from a scheduler. We have integrations with all of these things. But once your request hits the gateway, then we're going to actually provision instances if needed, so scale the clusters up if needed, and then start the containers, configure them, collect their logs, and make them visible in a web UI. And a big part of the value is in the fact that we are going to automatically scale and optimize the pipeline configurations. So typically some Spark configs, like the size of the containers, the type of instance to use, the default number of partitions, and so on. This isn't the topic for today, though, so I'm now going to focus more on the monitoring side of Spark, because here also, we thought that there were some pain points, monitoring Spark jobs, and we wanted to solve them at Data Mechanics. So first, how do we do this today? How do you monitor your Spark jobs today? Well, first, the most common option solution is the Spark UI. What the Spark UI looks like. You can see all your jobs, then your stages, and your task. But when we ask people, what they think of the Spark UI, there are a few things that always come back. First, it's hard to get the bird eye view. There's a lot of noise on the screen like that, and it's not obvious what you should focus on. It needs a bit of tribal knowledge. It needs maybe on this screen you will look at what is the longest job and stage. Um, if there's a problem, maybe this application that I took a screenshot from is very low because of some reason, because of some IO, or maybe it's running out of memory. But maybe this isn't visible at all, or maybe this isn't at least obvious. Um, the second issue is that there are no system metrics. So what I mean by that is the memory metrics, CPU, IO, there are very little kind of node or container metrics. And so if you want these kind of metrics, you will need to jump to another tool, a general purpose tool. And we talk about that later. And maybe a third flavor of pain point is the Spark UI is very easy to open up for applications that are live. But for applications that are finished, you need to run the Spark history server. If you run it yourself, it's a bit of setup and maintenance. And if you use a managed platform, well, probably it's still slow and not super user friendly. The second option are general purpose monitoring tools. And typically this screenshot is taken from Ganglia, which I think is used by a few managed platforms, including Databricks. Um, and these kind of tools, they were not built for Spark. So the issue with these tools is that it's hard to correlate the metrics you're seeing there with your code. Ideally, you'd like to know, oh, well, this spike here corresponds to the last, I don't know, stage of my job where I actually write the data back to S3. But this is, well, basically, you'll have to go with timestamps. And if you want to actually correlate what a specific, node or container metrics look like, you'll need to look at their IP and then match it on the Spark UI, which is pretty painful. In particular, if you just want to look at, what happens with the driver, I don't think it's obvious. And yeah, I mean, Ganglia is not the only tool, but in general, there's always a bit of it can be somewhat painful to set up. And even if you use a managed, commercial service, usually they're not very advanced when it comes to really Spark monitoring, and they can be expensive too. So these are some of the pain points that we wanted to address with Delight. So with Delight, we wanted to make it easy to troubleshoot performance and stability issues for Apache Spark users without having a PhD in Spark. So this was the vision with Delight. This is the animated GIF that we prototyped early on. So we wanted to show memory and CPU metrics, which are lacking from the Spark UI. And we wanted to align them on the same timeline as the Spark jobs and stages, such that it's very obvious that, oh, this part of my job had a high memory consumption because of this job or this stage. And we wanted to make problems obvious. Like there are a few, once you have a bit of expertise with Spark, there are a few things you know where to look at on the Spark UI, but for most people, it's really black magic. And the last thing we wanted to provide, and this isn't yet in production, but this is something we have in our roadmap, is to start giving people automated recommendations. Oh, we realized you suffer from data skew, and this is the data set, and this is the column that's problematic, these kind of things. And finally, make it easy to set up. And so I'll explain later what the architecture look like to achieve this. So we started this project about a year ago almost with just a blog post, but that created a lot of interest. And in November of last year, we released the MVP. The MVP didn't have any new screens yet. It was just a dashboard giving you access to a hosted Spark history server, so basically a hosted Spark UI for each application. It was pretty useful for people who use Spark on either on-premise or actually either on open source or not commercial platforms, including Spark and Kubernetes, because that meant they didn't have to run the Spark history server themselves. And yeah, earlier this year, we released new screens for Delight, first to our own customers, and for about, well, a month and a half, it's actually available for anyone, and it works on top of any Spark platform, and it is entirely free. So let me just explain the architecture of how it works. There are two pieces to Delight. There is the agent, which is basically a jar attached to your Spark application running inside the Spark driver. And this agent is open source. I'll show you later our GitHub project. And if you know a bit about Spark and the kind of interfaces it exposes, it is implemented as a Spark listener, meaning it will listen to the Spark events. And these are the same events that power the Spark UI. So the source data is the same as the Spark UI. And these events are going to be streamed to the data mechanics backend, which is hosted on our side. They're going to be sent securely. These event logs, this is really metadata about your Spark application. This is like, oh, this task ran for an hour and it read that much byte of data and it spilled that much bytes of data to disk and these kind of things. This is not the sensitive data that Spark itself works with. And you don't need to trust us for this. You can just check the code and make sure you can trust this agent. And then, once it's stored on the data mechanics backend, it will be automatically parsed and made available to the web app, the web dashboard at delight.datamechanics.co. And we're not holding up to this data forever. It will be automatically cleaned up after 30 days. So yeah, if you want to try it out, I'll say it again at the end, but basically it's easy. You just create an account on delight.datamechanics.co. You need that because when you create an account, you will also create a token that uniquely identifies you. And then you can install the open source agent. And for this, there are specific installation instructions for each major platform. Really, we have it for almost all the platforms. And obviously, when you do that, you will be providing the API token that you created in step 1. And then basically that's it. As you run Spark applications, as soon as they're completed, they will show up on the dashboard. So I think I have a couple of examples of installation instructions. For example, this is how it works in Databricks. You can install it using a feature of Databricks called Initscript, which is basically a bash script that runs on your cluster before Spark starts. And if you look at this little script, basically you need to provide the access token that you created earlier. And this access token will be put in a special Spark config. And we will also be downloading the Delight jar. And basically this is it. This is the script. And then you can define this as a global Initscript. And then automatically you will have access to the Delight UI for all your Databricks applications. I have another example on EMR, which also looks kind of similar to how you would do it in open source or using Spark Submit. You just need to provide a few additional flags to your Spark Submit options. So the package basically lets you download the Delight jar, and then listener and the access token is the thing you created earlier. So this is, and similarly, for other major Spark platforms, you can just see this on the GitHub. So now that we cover, how to install it and what the architecture is, I'm sure you wonder what it looks like and whether it's useful to you. So first, whenever you run a pipeline, when you log into delight.datamechanics.co, you'll have the list of the recently completed Spark applications. And so you'll see the name of your Spark application, its status, whether it completed successfully or whether it failed, when it started, how long it ran, the username. This really is the username this comes from the access token that you provided earlier. So note that delight can be shared within your organization. As long as you share the same login method, like SSO method, you'll have the same dashboard. And so this is how you could potentially find the application that are really yours, and you can filter by user up there. And then there are a few columns which you're probably less familiar with: Spark tasks, CPU efficiency. And I find, we found these metrics to be really useful to help you understand overall, is my Spark infrastructure efficient? Is it, or am I, wasting resources, wasting money? And so I'm just going to dive deeper into these three metrics. So the first one I want to explain is CPU uptime, which is basically this column that we see here. What is CPU uptime? Basically, it's the amount of executor cores, resources that you've used for your application. Let's assume you have a Spark application with 3 executors, and each executor has 2 cores each, and the application runs for exactly 1 hour. Well, then you just consumed 6 core hours of CPU uptime. So why is this metric interesting? Because then we're going to compare these 6 hours with the actual Spark tasks. So Spark task is the sum of the duration of all the Spark tasks in your application. And if you remember your Spark application, you type in code, which is going to be broken down into Spark jobs, stages, and task. And so one task is executed by one CPU core at a time. So what that means is that if your application is perfectly parallelized, you may have 6 core hours of uptime and 6 hours of Spark tasks. But here, when we look at this graph, we can see this isn't the case. We can see that this is probably a stage where we had one task that took a really long time to run, maybe a straggler, and all the other tasks finished quickly. And so when you sum the duration of all the Spark tasks, even though you had 6 core hours of capacity, you only run, a Spark task for a little over an hour. And so the ratio between these two metrics is the efficiency. And here, the efficiency would be about 20%. And that's bad news. I mean, it means really that 80% of the compute resources that we're running and that we were paying to the cloud provider or the managed platform you're using were wasted. So this metric is kind of interesting. And so, well, typically on the example I showed earlier, we had a notebook which had an efficiency of 17%, which is not that great. But unfortunately, it's pretty common for notebooks. It's typically harder to get good efficiency out of notebooks just because you're using them in an interactive way. And then we had an ETL pipeline which had a 80% efficiency, which is really good. It's hard to get to numbers over 90. So maybe now that we've explained efficiency, what are the typical causes that can drive low efficiency? Okay, what if you install Delight and you see that your efficiency is poor? Well, there are a few reasons. If you are using notebooks and if you are using Spark in an interactive way, then it's very important to enable dynamic allocation, meaning you will not be using a fixed number of executors. You will, when you need executors, you will get more of them, and when they're not needed, you will scale them down. That's very important, again, particularly for notebooks where you're likely to, I don't know, go to a meeting and take a 1 hour break. And so it's important to scale down your executors during that time. Another common cause is, well, you just specify a fixed number of executors, but you specify too many. Sometimes it's because you're using a single global configuration for all your apps, or sometimes you didn't realize, you thought you just really wanted the app to run faster. But when you provision too many executors, Spark may not be able to fully utilize them. Why? Because the number of tasks, so the parallelism level, depends on the number of partitions. And the number of partitions can come from 3 sources. It can come from the input data, and so this really depends on how the data is laid out, on S3 or on the object store. it can be something that you put in the application code, and sometimes people don't necessarily realize it, but they have a hard-coded number somewhere in their code, like they use a coalesce or repartition, and they have a small number of partitions. Or it can be the default number of partition, which is something you can configure using the Spark config, and the default number is 200. And so, on average, we recommend having at least 3x the number of partition as the number of executors. And that's, again, to guarantee good parallelism. What are our other common causes of inefficiency? Well, when the task duration is skewed, this is what happened in our example earlier when we had a very long task and then basically a straggler and then all the other short tasks. And very commonly, this is caused by data skew. And so for this, you need to change the application code logic. You need to maybe join a different key, or you need to see if you can filter out stragglers, or maybe you can use a technique called salting. What else could be causing poor inefficiency? Well, the type of committer you're using for Spark, where the committer is how you can save the data in an object store and write some metadata to basically make sure you have some guarantee of consistency and readability of this data. I cannot go too deep on this, but this could be worth an interesting deep down session by itself. And maybe one last common cause that we see is long periods of pure Spark driver work. So the when we compute the efficiency, we only look at executors. And most people who run Spark, when they handle really large volumes of data, that's what they care about, because they're going to have many executors and just a single driver. But some people use Spark in a different way. Maybe they actually use Spark in a distributed way, and then they collect the data on the driver, and then they run a pure Python code. But when they do that, it's only the driver that's doing the work, and all the executors are idle. And so we're coming back to our earlier point, where in this scenario, it's very important to enable dynamic allocation, such that when you do the driver-only work, the executors go away. So I hope this was useful. We could dive deeper into some of these bullet points if someone has questions, either now or at the end. The next thing I wanted to cover is basically so we've seen the general dashboard with the high-level metrics, and now I want to show you what it looks like when you actually dive deeper into a specific Spark application. So we call that the overview screen. And so the first screen we're going to show looks like this. It's called Executor Cores Usage Breakdown. So what does that mean? It means that we're going to show you at the bottom a timeline of your Spark jobs and stages. And here at the top, we're going to tell you for each specific time interval, what Spark was busy doing with. And so there are a few different categories, which I'll explain on the next slide. But just this graph gives you lots of very obvious information that are not that easy to parse from the Spark UI. Typically, you can see how many executors and CPU cores were available over time. So here we can see, oh, we scaled up, and then we actually scaled down and remove all the executors. Probably this application is a notebook, and it was a bit interactive and bursty. And then 15 minutes later, whoop, we scaled up, we did some work, and then we scaled down again. So here we can see that if you look at the line underneath, you can see when executors are added and removed. And so it's pretty clear that dynamic allocation did its job. And so as your application was going idle, the executors were removed. But here, for some reason, it didn't. And so somebody ran a query on the notebook, the application scaled up, and then the executors stayed there. And so you have a 50 minutes period where nothing was running. We're in all cores idle. And so here you're clearly wasting resources. So these are some of the pretty obvious things that we wanted to show with Delight, and that I think are not so obvious from the Spark UI. And we think that most of the savings you can do on a Spark application, they come from pretty simple observations like this. Maybe to dive a little deeper into these different colors and these different categories we had there. So the gray ones are bad. The dark gray means that all cores are idle. So either your application is fully idle or you're doing driver-only work. The light gray means that some CPU cores are idle. So typically this can happen when you have this straggler situation, where you have maybe one core running a task and then the rest of the cluster idle, waiting on this task to finish. The next two categories are the normal ones, so CPU uptime. This is when Spark actually uses CPU power to run your task. And I/O, this is when Spark is waiting either from data to be downloaded or to be written. It could be to the disk, it could be to S3. Unfortunately, we don't have the detail of that, but we know that it's some kind of I/O. Shuffle is interesting. It's usually, well, bad, though obviously you cannot always avoid it. But shuffle is when you're waiting on data to be read or written to be exchanged during the shuffle phase, which is a phase where executors send data across the clusters. So they send data to each other. There are some techniques to avoid shuffle. It can be a change in your code. There are some techniques to speed up shuffle. We will see one later in this talk. And the two last categories, well, they should be really small in percentage value. Otherwise, you have really something unhealthy and weird going on. But you have the JVM garbage collection, which will always be just at most a few percentage points. Otherwise, it means you're really churning through a lot of memory, and you need to look into memory usage. And Spark internals, which is typically some categories that you will see in the Spark UI, like scheduler delay, task serialization, deserialization. And again, this should be small. So if for some reason your Spark internals are high, you should look into that. One last thing that we show on the on this overview page is the memory breakdown, the memory usage breakdown of the executors when they were at their peak memory usage. So this section is getting improved on, and later I will show you some plans we have to improve it. But our goal with this screen is just to show you if you are maybe running close to running out of memory, or if you have sufficient headroom. So you will see the breakdown between memory usage used by the JVM and maybe used by Python, or maybe even used by other processes, R, for example, or if you're running, I don't know, some system libraries, they could fall into other. And so with this information, we want to show you, oh, well, maybe this first executor was using all its memory, and so maybe this isn't great, and there's a risk of the executor dying because of an out-of-memory error. In fact, this is a screenshot where we can clearly see there's a little exclamation mark here. It's not from the slides, it's really from our interface, and if you hover over it, you will see the executor kill reason, and here it was killed. So yeah, this is something we wanted to, mostly we wanted to give this feedback to developers, because out-of-memory error is probably the #1 error that people run into with Spark, and it can be a bit frustrating and painful to debug. And so we hope this will help a little bit. And I will show you what we're planning to do in the next stages for Delight. So now that I've presented the screens at a really high level, I want to dive into a few specific examples of how to do, tuning with Delight. So I actually got permission from a couple of customers to, to show. These are sample examples, but yeah, they're real world examples. So we're going to look at an example from Weather 2020, which is great, which is one of our customers. They're a weather analytics platform. And so here I directly clicked into the application overview page of Delight. We can see some statistics up here. Oh, it read about 100 gigabytes of data. For some reason, it didn't write any data. It ran for 15 minutes. The efficiency score, 1 hour 38 divided by 3 hour 50, is 42%, which isn't that great. So yeah, well, can we try to understand why? So as I told you, the gray areas are bad. And so typically here we can see a very big gray area. So obviously this is our culprit. We can also see that between job 1 and job 3, there was a small break. This isn't, if this was, I don't know, running for 10, 20 minutes, this would be bad. But here for 30 seconds or 20 seconds, this isn't a big deal. This is probably just the time, Spark sometimes need to actually process your code and create its plan of attack. And so this is probably what happened there. But here, very clearly the the culprit is this big section. So if we're trying to understand, well, to dive deeper into it, unfortunately, right now we still need to go to the Spark UI. Okay, we didn't replace all the screens yet, but you can click here, and this will directly take you to the interesting stage. And here you still need to have some, some knowledge of Spark. But what's pretty interesting here is you see there are 2 completed tasks. And so what this means is that for this stage that took, I don't know, it took 9 minutes to run, we had only 2 tasks, even though the cluster had, well, about 16 CPU cores provisioned. And so that means that for these 8 minutes, we will be using maybe 2 cores out of 16. So that is why we had a big, parallelism issue. And so this is where you then need to figure out, why do I only have 2 tasks? Is this because I'm reading only two files, on my object store? Is it because I did a coalesce or a partition? Is it because my default number of partition is 2? And so for this, you could dive deeper. You could go into the SQL tab, or you could look at the driver logs. Here, in the interest of time, I'm not going to dive too deep into it. But this is something you can fix, and you can definitely define more tasks, and then get a really good parallelism, and really you could get the same job done in half the time if you manage to parallelize this section a little better. So moving to another example, and this is from Jellyfish, which is a AdTech, MarTech company. And here we're going to look at a slow shuffle example. So as I told you earlier, shuffle, it's whenever in Spark you exchange data across all your Spark executors. And yeah, it's very common whenever you work with very large data sets in Spark, you run into shuffle. The bad news is that you don't necessarily realize when you look at the Spark UI that an application is suffering from slow shuffle. But here, when you look at Delight and when you see this big purple section, you immediately see that shuffle is what you should focus on if you want to improve the performance of your application. Note that shuffle doesn't count as inefficiency. It's not, the Spark cores are not idle. They're writing or reading data, but all this writing and reading is related to shuffle. And when it's that big, it may be that something fishy is going on. Just to show you that the Spark UI, wouldn't help a lot, let me just bring it up. Maybe the Spark UI will take a little more time to load because I think there's a lot more data underneath. This is how things go when you go live. Sometimes it takes more time. This is the Spark UI. But yeah, here we go. So if you wanted to understand what was going on from the Spark UI, it wouldn't be obvious. You would know that, oh, this is the stage, the job that took a long time, 1.8 hours. But there is no indication that it's slow because of shuffle. Even if you dive deeper into it, oh, you see, oh, well, this stage took an hour and a half, 200 tasks. But it is not obvious that it is because of shuffle. You will need to look at some metrics here, like, oh, shuffle read, shuffle remote read, and maybe realize that indeed the slow tasks are correlated with large volumes of data, shuffle, and see that there's shuffle spill. But you need to have not quite a PhD, but a decent amount of Spark knowledge to figure this out. So after figuring this out, there was one change that was done, and basically it was to use to mount local SSDs inside the Spark pods. Again, I don't want to diverge too much, but just to explain why it had a big impact, during shuffle phases, Spark first writes the data to disk. And so when there's large volume of data that needs to be written, the fact of writing to disk can become the bottleneck. And local SSDs, they provide a much better bandwidth than traditional disk like EBS volumes. In fact, 5 to 10x. And so when we did our own internal benchmarks of data mechanics, we realized that for shuffle bound pipelines, you could get a 10x performance improvements by attaching local SSDs. And here, well, it was very obvious on this app. So now let's open up the same Delight screen after optimization. Well, it's not obvious, but the shuffle that used to take 50 or 60% of the resources is now less than 1%. And the application that used to run in 2 hours and used, I don't know, 180 hours of CPU uptime, it now runs in 26 minutes and it uses, half the resources. We can see that it's not perfect. There is still something fishy going on with some low utilization here. So, that's how performance tuning works. It's iterative. But these are some of the optimizations that you can do based on the feedback from Delight. And these are some of the optimizations that will be automatically done if you are a data mechanics customer. So I think I have one slide that kind of shows the two screens back to back. But here, it's pretty clear. Actually, this not exactly the same number as before, but I think it is the same pipeline, and it went from 4 hours 20 minutes to 26 minutes of runtime. So really much faster. I think this covered a couple of real-world examples that I wanted to give. I want to give you a few, tell you a bit more about the roadmap, what's coming ahead, and then I'd love to leave the mic open to questions and get your feedback. So one thing that we are working on, I kind of touched based on this earlier, is the memory plots, where earlier what we could show you on the overview screen is the memory usage at peak capacity, but you don't know when the peak, when you reach that peak. And so here we just want to give you a regular memory plot of usage over time. And so you are able to correlate, the memory usage really spiked when job 10 or job 11 started. And we want to provide this both for the driver and for all the executors, because these are different flavors. Typically, memory issues on the driver and the executors can happen at very different times, and they have different consequences. If you run out of memory on the driver, then your entire application is interrupted and fails. Well, maybe for the executors, they can recover. And again, this plot will be aligned with the Spark jobs and stages, and it will be broken down by different types of memory usage. If you're curious, if you know a little bit about how we can get these metrics, well, we are actually implementing it using a more powerful mechanism called Spark plugin, which is a bit more powerful than the default memory metrics that are available in Spark 3.0. And this is how we can get more fine-grained and more detailed data. So this is work in progress, and then we have a few other items, lined up on the roadmap based on customer feedback. One of them is to make Delight accessible while the app is running, because right now we need to wait until the app is completed until you see Delight. One of the consequences that it'll be possible and to better support streaming application or just long-running application. Another common feature request is the ability to log in using email and password, because right now you need to have a Google account. It can be a personal Gmail account, or it can be your company Google account. Both work. If you use a company Google account, then you can share your screen with your colleagues. And then it's to provide some automated recommendations, and so that will be a screen that will be available for each specific application, Or another common request is to generate more broader cost reports, where it's not about one application, but more high-level view, high-level dashboard. And yeah, what else? I'd love to know what else you wish to see. I'd love to take your feedback into the roadmap. So as a quick reminder to wrap up, you can try out Delight for free. It works on top of any Spark platform, including Databricks, EMR, Dataproc, Azure HD Insights, MapR, Hortonworks data platform, Cloudera data platform, Spark on Kubernetes open source, Glue. It works with Livy. So I really think you should be covered. If you're not, let us know, and we'll love to add a bit of documentation to show you how it works on your platform. And so you basically create an account, and then you sign up on our GitHub page. And I didn't show the GitHub, but I'll send it to you afterwards. It's github.com/datamechanics/delight. And actually, my Chrome is very slow, so yeah, here we go. I'll send it to you afterwards. And so now, yeah, I'd love to take some questions. Thank you so much for the listening.
Great talks, a great project. So let me probably I'll ask my question first, and then I'll let audience either post your questions or directly just somehow raise your hands and I can unmute you. So from the end of almost the last slides, so it sounds like this doesn't support a long-running cluster or streaming, so it's mainly for batch process monitoring. And so it's also kind of like a dynamic clusters in the Databricks sense. Essentially, I start a cluster, shut down the jobs. Essentially, that scenario, right?
Yeah, correct. Why we want to make it such that it supports streaming and long-running clusters. Right now, we just wanted to get an MVP out and get some user feedback. And so indeed, we collect all the logs, and then once they're finished streaming, we process them. But we started actually the work to process them as they go. And so indeed, soon we'll be able to provide support for streaming and long-running applications. But yeah, right now, most Delight users, they just use it for batch ETL applications, maybe on transient clusters, just like you said.
I see. So we're using Databricks. So essentially, we majority, almost all our batch jobs essentially just start the clusters, run the jobs, shut down the cluster. So I mean, we frankly don't shut down the cluster, just let it idle for 10 minutes and shut it down by itself. So so in that case, you literally just during the startup, I can insert that Initscript, and that will before create a cluster, and that'll happen, make that happen, correct?
Yeah, absolutely. Let me maybe show you quickly what it could look like. I'm just going to log in to the data mechanics. And so, yeah, here, all these applications, they correspond to like a Databricks cluster that was started, that ran. You also have access to the Spark UI. And yeah, let's see, maybe I can even quickly log into Databricks and show you what an Initscript could look like. Here we go. I think here, admin console, this is where you could define a global Initscript. And so the Delight global Initscript does basically what I told you earlier. So this is the API key that you would create on the Delight side. Maybe just to show you, if you go here under settings, you could create a token, and so you could say, well, June 21st. And so this is the new token that I could paste here. And then the rest is basically downloading a jar, putting it on the right place on the Spark driver, and then passing in the secret you just created.
Okay, got it. So you just define once, and all the cluster starts will trigger to run the scripts. Okay.
Exactly.
So my next question is, which version of Spark it supports? So it's like a 2.4 or 3.0, or what's?
Yeah, it works with all Spark versions, but there are a few features that require 3.0. Basically, I think the way we implemented memory metrics right now require 3.0. So if you use 2.4, you will not get memory metrics. With the new implementation that we're working on using the Spark plugin, I think this limitation may not be around. But if you're using to all the first the basic delight graph will still work, and for the specific screens that do not work, you'll see an error message that warns you and advises you to upgrade your Spark version.
Very cool. Thank you. So anybody has questions, please post it on the chat or somehow raise your hand so I can unmute you. We only got a very small crew. Maybe I just unmute everybody to see anybody want to talk. Let's see. Oh, somebody asked for unmute. Let me unmute. How do I do that? Shoot.
Hey, thanks, JY, for the fantastic presentation. I was curious, like, what are the ways that users can interact with Delight?
Yeah, what are the ways that users can interact with Delight? So most people, they would first, install Delight. For example, like I've shown you on Databricks, or maybe using EMR by specifying it in their Spark submit arguments. And then, automatically as they run applications, Delight will become available on their dashboard at delight.datamechanics.co. And then people typically, they go there either as a general dashboard, well, for example, we have Spark and Kubernetes, users who don't really have any kind of dashboard to track their apps. And so they use that, and, maybe in the morning they log in and they make sure that their pipelines that were supposed to run last night, they completed successfully. So that's one of the ways. And the other way is maybe you're already using a commercial platform like Databricks, but you find, your manager or yourself, you're pretty concerned about your overall costs and want to reduce them. And then you can use Delight to figure out, what is the efficiency of my pipelines, and are there some low-hanging fruits to improve it? And so then you could, use Delight more on an on-demand basis to understand the performance of each specific application. And it's not just performance sometimes, it's stability. Oh, my application crashed, ran out of memory, why, which stage, and so on. And so either you log into the Delight dashboard, and then you can filter by your username. You can look for your Spark app name. Or you can also directly access the right URL because it's printed in the Spark driver logs. So if you have an easy access to the Spark driver logs, you go at the top and you'll see that the Delight listener will print the URL at which the application will become available.
Very cool. Thank you.
Of course.
I'm not quite sure this is how I enabled unmute or not. Apparently somebody able to ask the question. So if you have a question, you can unmute yourself or post to the chat. So while waiting for others to ask question, I maybe ask one more question. Your test, I think you're hinted on your future roadmaps. It's cool to see, what's happened correlated with your, the actual jobs, whether executors or data. I think the second part is say, okay, suppose they say, hey, that's cool. You told me that. What am I supposed to do about it? So the recommendation part is say, hey, can you tell me? Say, hey, should I, what's the recommended approach? There's maybe, depends on the actual use cases. There may be 3 or 4, but you can probably, based on your past experience or most of the cases you've seen, say, hey, here's the 5 common steps usually people may take. And like, for example, you just say, hey, look at the parallelizations here. Look at you maybe need adding a disk to reduce the shuffle speed, or maybe you had external shuffle services, or any other recommended in the steps. So I can more concrete, so I can do something about it.
Yep. No, absolutely. That's a great point, and that really aligns with our mission at Data Mechanics, because so we're developing Delight as a free tool for the community, but we also have our commercial platform, which is deployed on Spark and Kubernetes. And on the Data Mechanics platform, we automate a lot of the tuning decisions to try to make pipelines as efficient as possible.
Mhm.
So typically what we tune is the number of Spark executors, the type of instance you use, the default number of partitions, the memory tuning, etc. And some of these things can be automated, and on average, this has a big impact on our customers' pipeline. I think we typically see a 2x overall performance efficiency improvement. And the other type of feedback you want is when you actually need to understand as a developer what's going on in your application, because you need to change the application code. If you realize that you have some straggler because some task is very long, there's a skew in your data, then we cannot automatically fix it for you. And so this is where Delight is very complementary, because in Delight, we're going to be adding some recommendations to make the problems obvious. We might not be able to automatically rewrite the code to you, but we want to tell you, well, this is your Spark. 80% of your resources were spent on this specific stage, and it was very long because the data was skewed, and the data was partitioned by this column, and these are maybe the specific keys that are responsible for the skew, and let's see if you can do something about it. So yeah, this is where we want to go further and automatically provide this kind of feedback in the Delight UI. And the reason we're doing this is because within data mechanics, we also parse the kind of same logs to take some automated action. And so right now we focus on the low-hanging fruits, which are more around memory tuning, instance type, number of executors. But the next stage is to give users the insights they need to write better Spark applications. And so yeah, hopefully later this year, we're all really excited about this.
This is pretty cool. The other one, not directly related to this particular topic per se, but just in company in general, your layout of your company data mechanics kind of overall picture, looks like it's similar to what Databricks are also offering as well. So because they also do the automated Spark tuning on their own. You work there, so so the platform tuning and all that stuff. So there seems like there's overlapping. Or are you targeting this kind of same space?
Yeah, the great question. I get this asked all the time. So yeah, don't be embarrassed to ask. I know the two platforms really well. Yeah, definitely. I mean, it's good that you have a few different options when you look for a vendor. To give some credits to Databricks, I think it's a pretty powerful product when your use case is mostly about data science. Because with Databricks, you're not just buying an infrastructure, you're buying an environment development. You're buying maybe their hosted notebooks, or you like their integrated job scheduler. This being said, I mean, these features, they come at a price, both in terms of money, like on average, they do charge a heavy premium, and also in terms of vendor lock-in. A lot of the features they implement to make Spark easy will also make it harder to migrate out of Databricks. With data mechanics, we wanted to focus on the number one pain point that data engineers have. Like data engineers, they're pretty comfortable, calling an API. They're pretty comfortable with building their Spark application. Maybe they don't want to be mostly working from notebooks. This being said, they don't want to be managing the Spark infrastructure. And so this is what we fully automate, and we try to give them a serverless experience. We automate the provisioning of the VMs. We automate the collection of the logs. We automate a lot of the tuning decisions to make Spark more efficient. We don't do this by modifying Spark code. It's not proprietary changes of Spark, but it's serverless automated infrastructure. And yeah, on average, we've been able to reduce our customers' cost by 50 to 75% when they're coming from Databricks. So yeah, if you're interested, I don't want to make this too much of a commercial pitch, but I'm really happy to talk about this and not make this just generic, but try to understand your specific use case, your needs, and see if we can be a fit. But yeah, on average, if you're a data engineer, if you're pretty technical, if maybe you already use, I don't know, you already use Airflow, you don't necessarily need all features that Databricks offers, but you really need a partner that will handle the Spark infrastructure really well. I think we can be that partner.
Got it. Anybody has any other questions? I think I try to unmute everybody, but I don't know I did it successful or not. But if
Chester, maybe this is a question for you and some of the others in the audience. I'm curious, like, how often do you use Spark Submit as a vehicle to interact with your Spark environments, whether be on EMR or otherwise?
I can tell you my experience, and we directly using, we're running on Databricks platform. So our batch jobs are directly calls the Spark, REST APIs. So essentially not using the Spark Submit at all. So we basically write a Python driver in front of it and just load the configuration. So all our platforms actually, have our own command line, which is in turn calls the Spark API, including creating clusters, shutdown clusters, storage jobs, and all that stuff. So those, so I don't, I couldn't relate it to that particular one. So I'm sure the audience is probably using Spark Submit to somebody else.
Have you used Spark Submit in any other places or in your prior roles, or outside the scope of?
Definitely. I mean, before I joined my current GoPro, I was at the previous startups, and we use Spark Submit all the time. Yeah.
And how did you, like, what was the workflow? Like, would you integrate Spark Submit in some sort of like workflow management tooling via cron jobs or step functions or Lambda or your own home build?
When we started using Spark Submit, that was early stage. So basically everything is running either on the Hadoop clusters. And so we're a startup working all up cluster like actually in what's the IBM's what's called actually inside or whatever that cluster MapR and Hortonworks and Cloudera clusters. And so those are we running on those ones, and then we usually running on yarns. So you run some, you create a client side or cluster side, so whatever the mode is, and then you run on that. So I don't think we were not running on the cloud that time. So.
Got it. I mean, do you think the Spark Submit design pattern is more associated with Hadoop and Yarn as opposed to Spark, and like particularly people who are running via Databricks or via EMR or Dataproc or some of the more native like Spark or Kubernetes solutions?
Yeah, Jean-Yves probably can answer that question. He's from Databricks and he have managed that internally. So you probably have a better, exposed to all different cloud services.
Yeah, would love to hear both of your thoughts.
Yeah. So personally, Spark Submit, earlier in the demo, we've shown the installation instructions for EMR. And so on EMR, you actually have Spark Submit arguments. But other than that, from my experience, most commercial Spark platform in the cloud do not support Spark Submit as a first-class citizen. Databricks doesn't. I think Dataproc doesn't. Yeah. So, but then again, this is one data point. Maybe Chester or someone else can also comment.
I like to hear others, and because we haven't really used that for so long. At least 5 years since I hear. So whatever I used that was 6, 7 years ago. So it's probably irrelevant at this point.
So I've just posted on the chat my my LinkedIn. So for people who are interested, maybe have some follow-up questions or just are generally interested to connect, feel free to do that. And yeah, like I said, I regularly post, blog posts and so on LinkedIn, and you might see an interesting announcement coming from us soon. So feel free to connect, and I will not say more. Chester, the session has been recorded. Will you kind of make the recording available? I could also send you the slides.
Yeah, definitely. So I'll share the slides on the meetup page, and as well as the post the recording on the YouTube, and then I'll put the URLs there as well. So I usually do another post on the LinkedIn just to, make sure that people who didn't attend this also can wear the talks. So I think we are about, just over an hour. So I think if you have no more questions, so we'll stop here. Thank you, Jin, and for the great talk again, as usual. So thank you everybody who will make it, and from different places of the world. We'll wait for the next event for July sometimes, and I haven't really decided what topics yet. But thank you all. Okay, bye-bye. See you next time.
Thank you so much,
Thank you.
Chester. Thank you, everyone.
Thank you, everybody.